of operation. Okay. So as soon as the power comes down to transformer, right down here, you got a piggyback wire.
Yeah.
You got a piggyback wire going to L1 and going into power 120 volt primary side of the transformer. Right? Got a neutral wire. Transformer take that 120 volt, reduce it down to 24 volts. If it goes to a thermostat causes heat, it'll come back down. If it don't, and you have this, it'll connect to a loading controller. 24 will be sent right to W. Control board get powered. As soon as the control board get powered, PSI sends out 24 volts. 24 volts sends to the air cooling switch. The 120 volt that was sent to the board earlier comes back out on the relay internal on the motor wire. Motor starts up, closes the switch, 24 volt, returns back on PSO. Control board satisfied, that's a pre-purge sequel. It stops, 120 volt sends out on the red wire, igniter starts glowing bright orange. Give it about a couple of seconds. Timing internally to the board. 120 volts sends back out to the 24 volt on IND on PS1 is always there. That 24 volt is always present. It's always going to be sending that 24 volt here. So when the switch is open, that's fine. It knows that it's not in that particular sequence, so it's fine. 120 volt sends back out to the motor, closes the switch. That 24 volt comes back to the board. As soon as it comes back to the board, 24 volt sends out on GB to the high limit, to the gas. Gas valve is good. Get energized from a 24 volt AC. Both solenoid lift. Gas flow 13 inches come through. Reduce it down to LP 10 inches, the burner manifold. Goes up to the burner casting, ignited by the hot igniter. You get flame. Flame sensor take over. That 24, that little voltage sent from this purple wire is now converted over to DC volt. Comes back on the ground wire, back to the board. Board recognizes that voltage, allows the gas flow to stay open, allows the 24 volt to continue to flow. Thermostat satisfied, AC cut the 24 volt off. Loading controller is outside, shut the 24 volt off. And the sequence starts all over again when it's all Alright? Now, troubleshooting. Yeah,
One quick question. Say somebody had low gas pressure, you want to heat it. What kind of flash panel did you see on it?
Low flash panel will be a flame sensing issue, so that'll be more of a 3 flash or a 2 second on, 2 second off, depending on what time you get there. If it's a 2 on, 2 off, that is 15-minute wait. It doesn't pick up enough flame. It doesn't pick up, that rod is not picking up enough flame from that low pressure. So it shuts the heater off and it's telling you that it failed for ignition. Even though there is flame present, it just wasn't enough to convert that to DC back to the ground.
Are you guys seeing that out there? I mean, there's what, 3 or 4 years ago, we had good issues on certain sites with low gas pressure, right? They converted over to beam to finish.
Well, we're tying those there with the system using.
Right. So we were, yeah, so we kind of switched all that around. I think we kind of solved the problem. You guys ever have a situation where you think it's low gas pressure?
Yeah, I've had it where you'll only see like half a flame coming out of the chimney.
Or really yellow flame, not really green.
Yeah.
So yellow flames, okay.
Yeah, now that's the flame.
Yep.
If you're seeing a partially flame coming out of the burner casting, check for blockage. There might be something blocking the throat of the casting, or something on top, even a port opening. Might be a couple of the valve web. There's no flame sitting right there, so it's just gas and air flowing through there. So it's not going to burn it out. It's not going to burn itself out, that opening. It's not going to burn whatever's there. So you have to take a look at that, take a look at the probe. The yellow flame, check the valve, make sure it hasn't been converted to natural gas. Check for any obstruction of the orifice that might be diverting the flame a little bit one way or the other.
Or do you guys have pressure testers? You do have pressure testers, I know that.
And I'll show you where I'm at on the valve too, to kind of ease a little bit on that. Continuity test. Continuity test is the best friend out here when you're doing the switches. Air coolant switches, high limit switches, you can check those right away if they're bad. Just running a continuity check on those guys. Yeah. Basically, the continuity, mine's an automatic one, a Fluke automatic, so it automatically senses what I'm doing. Right now, it's by picking up the continuity. You hear that beep? Basically, just complete the circuit. So if you hold these two here now, you can get it on one bit. Alright, go ahead. Yeah. So if you click that and it's still not beeping, that internal mechanism is broken. You just need to replace it. So if you do that, then that's good. That's a good switch. You don't have to worry about switching that guy out. It'll just be a waste of components for you guys, waste of time for you guys to take it out and install this all the time. Your switch is fine on that particular point. Now this switch is a normally open switch. That means it's always open until something closes it, airflow or manually. This one is actually a normally closed switch, so you should beep right away. Alright? If you have it open, that's a bad switch. Okay? Just give it a reset, give it a good strong push in it, try it again. If it doesn't, what you gonna do is take these two terminals, get yourself a little piggyback wire, connect them right away. You can jump them, test. Alright, with testing, you can jump them, then you get it back on. If it takes off and run, no matter how much you reset this guy, it's not gonna reset. You just got a bad switch. Alright, replace that switch, put it back together. Don't leave it in the jumper terminal. Alright, that switch is a safety device, it's there for a reason. If you get out there and somebody did that, let them know they cannot do that. If they have a potential issue, a fire, it's because they bypassed it. The heater doesn't know how to shut off now. Alright, so test it. If it's good, replace it, put it back on. If you don't have a switch, just take it out of service. Now the gas valve. The gas valve have two Allen plugs. One on the outlet, which is right on the left hand side, one on the inlet side. That's your inlet pressure, that's your burner manifold pressure. Alright? So you take an Allen screw, an Allen wrench, 316 Allen wrench, take that plug off, hit the pressure bar, tighten it in there, take your pressure gauge. It could be a manual, it could be an analog, it could be a digital. As long as you have it to inches of water tower, that's what you're checking, inches of water tower. Put it on there, take a look at it. You got 13 inches coming in, you're fine. You got 10 inches leaving, the valve is working fine. There's something else between here, up here, that's preventing that ignition, the gas from getting off it. Alright? If you got 13 inches coming in, and you tap it over here and you got nothing, you hear a click, nothing's coming out, you're not getting 10 inches. Your valve is bad. One of your solenoids, dual solenoid, one of them is bad. Even though you're hearing that click, one of them is bad. If you don't hear a click, definitely it's bad. Again, 13 inches, the valve, the Honeywell gas out here, that pressure is maxed out at 1 psi. 1 psi or more, this valve will make sure that you are getting at least 13 inches in. Minimum is 11, maximum